Hi everyone! Well, long time no see, but that in a while. First let me say sorry because of this video is being recorded by myself like a selfie video. Quality won't be that much, not that the other videos were. This one will be even worse. Anyway, about content. Last video I did was just right after the Maker Fair, and I had a lot of ideas to try out. For example, the CoreXY, which I'm trying to show you right now. Okay, you can see it with front motors instead of the old rear motors, and just two bells, same size, not same tension. That's the problem I've been arguing with for the last 3 months. Yeah, it seemed a lot easier than the old movement system I was using, the one you can see in the photo, which had two parallel wired belts running along the chassis and one X belt like an H-bot with a motor that was sitting right there in the back. Unfortunately, I couldn't manage to make this one work. The CoreXY is a very nice moving system, but unfortunately it takes two things to work at all, because remember that we are trying to move something in a very precise mode, and we don't want nothing to go wrong. For example, the circles, we want them to be perfectly circle. The squares, we want to have them to be on equal length on all sides, both axes, let's say more correctly. And well, this totally doesn't do anything of that. When I started with part CoreXY, sorry, that's the Italian, CoreXY, and part old movement system, because I started using only this one printer because at that time I had only this one. So I started printing and replacing piece by piece every part of it, and initially it worked. I had perfectly round circles, I had very nice prints, but some issues with some diagonal lines on some circles, and that started puzzling me. And the more I got forward on the CoreXY system, and the worse the problem got. So for now I have a full CoreXY system, and it's total crap, totally. Now, a friend of mine who also brought here some of his printers, for example, this TAS 5 and this i3 rework, which now me and my friend are currently using to make new printers. We assembled this one, which is like a small nutsbot. I mean, nothing exceptional on the new things. It's the same design I did for the carriage, for the extruder shuttle, but we added, as you can see also here, the CoreXY. Now, here we have perfect circles, no wobbling at all. We were just trying it with a 1mm nozzle, which is quite huge, you know, with this little predator thing, but without any fill, because we had just a few meters of filament and we were just trying it out. Now I can we spread some paint over it, and as you can see, yes, there are some extrusion problems, and also I won't say it's wobbling, it's something else, but maybe it's because this printer is much more a prototype than my nutsbot, and the carriages are not so stiff. It has broken, as you can see. Then it's difficult. I need my cameraman back. Marco, please come back. He found a job, so actually is unavailable. So the printers, yes, we are currently trying to fix this one because we still want to find a way to have a large printer. This one still have half a meter for, per axis of movement and no wobbling at all, I can assure you, as this one now, because also the Natsbot has no more wobbling like this one had, but this was a print I did like 2.5 years ago, when there was still, I think, 2 LED screws driving the Z axis, not 4 as it is now. Oh wait, yes, a lot of things have changed in the last 3 months. So, not only the CoreXY, not only all the printers, not only this friend of us of me and Andrea that came with us playing with the printers, we also did a lot of modification to the NAS, but not only the CoreXY, but also the print bed. Now, as you can see, it has 5 beams running along under it, under the print bed, and also very, very large, how to call them? I don't know. Anyway, this piece, as you can see, runs along this column like using a smooth rod. Okay, it's not. I've seen it's not necessary to use a smooth rod in this case because you know, less parts, better project, and so I've worked a lot with my friends also, and we came up with these pieces and they work. I'm unfortunately still waiting new materials to come and try new pieces, trying new carriages. Well, I told you that there has been a lot of things moving on, and we try new things, etc., etc. For example, remember this one? This has been a carriage, sorry, that was moving along. Should have been there. I do remember correctly. It was the first one with skateboard wheels. And I will never thank Bruno enough for this suggestion because it really made the printer totally silent. So then we, as I told you, started moving on the CoreXY. For example, those carriages, they had 5 wheels, 3 on the horizontal part, 2 on the vertical part, and of course our old bearing friends, skateboard bearings. And guess what? Perfect carriage, totally not stiff system. So didn't work out. We even tried. Should you be interested in no wheel carriages? Yes, yes. Actually, they did work for a time because PLA totally, as you can see, skates. Seems like I love skateboards, but this one, no skateboard, just skating on it. No friction at all, totally. Well, I'm not the first one trying this. I've made some research. There are some people which use the same thing with aluminum extrusion profiles and printed skates like that one on little Prusas, and they work. So I decided to give it a try, and well, it worked, but you still have to, on the CoreXY, to totally make the carriage perfectly bound to the thing you choose to make it run on. For example, I have this extrusion profile, and I had to make it work by totally bending it to it, and that caused a lot of friction. As long as you just have to make it slide over it, there's no problem. PLA works great, but not for this one. Maybe it would have worked for that, for the shuttle, the green part you see there, but was a total failure here. So we tried a lot of other designs. For example, this one, which was promising. We had the old bearings system. It's quite heavy, and well, unfortunately, the main difference between, let's see, where it is. Where's the old carriage? Oh, there it is. Okay, so this one is the one that we moved on. Double extruder. Another thing that I choose to remove. I'll tell you why in a short while. And double fan with they were not standard fans. No, they were. Let me show you again. It's very difficult. Okay. Okay, those things over there, you maybe have seen them on the Facebook page of the printer. They are server fans that I took off old servers, the power supply, sorry, like this one. That thing, that small thing, moves a lot of air, so much that we successfully printed 60 centimeters bridges over nothing but thin air, because as soon as the filament moved through the nozzle, which, by the way, another modification that we did, silicone RTV silicone gasket that we molded and poured on the Vulcano nozzle, it worked flawlessly. Because when we used that fan without the silicone gasket, no, not gasket, sorry, silicone glove, when we were using it without, by only putting the fan to, let's say, 20%, it made the hot end cool down so fast that the electronics say decoupled. You know, when the thermistor goes in fault, or, or at least the electronics thinks so. Anyway, um, we were trying to, let's go back to the carriage. It had a lot of improvements. Now, it was a lot stiff. It has had those round holes over there, the holes for those two fans, and I suggest you go see the video of them running on the Facebook page. And well, it was for the CoreXY, and it worked. Was one of the things that worked, but not that good. I mean, the circles, they were coming out like, let's say, an arch, then a diagonal, another arch, another diagonal, closing the loop. It seems that that problem was about different tension on the two belts that move the carriage around, and to solve that problem, I had to apply an equal tension to both of the belts. Now, since I was using one tensioner that by moving it here near the corner, I pushed the belt a lot and added tension to the belt. Now, so that's my tensioner in short words. And if I pull it more over here, I pull more on this belt, on the topmost belt. If I put it the other one over the corner, I put tension on the lower belt. So it worked, but not much. The problem was still there. All the circles being ruined, and the square parts were not so good. The best thing I got, for example, this test cylinder single wall. I don't know if you can, let me see if I can make it clearer to you. Okay, now where I'm touching the cylinder, you can see the diagonal I was talking about. You see, there is this sharp corner. Well, not that sharp, but you see, there is a corner here and one other here, close where the layer starts, and make the typical signature of the fiber being extruded. Anyway, so that problem was totally make me waste a lot of time trying to avoid it. Now, remember, on that printer, it worked easily, smoothly and easily. On this one, no. Now, the movement is the same, the pieces very similar. The only thing different maybe here is that these Y carriages, they have those V wheels that, as you can see, are totally not good for this extrusion profile, because it has 8mm holes. And those wheels, they are designed for a 6mm hole inside the profile, and so they touch the borders of that hole by a tiny little part, which is not good, but still it works. Anyway, so what I'm trying to do with the nuts bolt, I'm trying to go back to the Cartesian system. Now, it worked nice. I've printed, for example, this Terran Marine boot, which, by the way, thanks to my friend Andrea, I'm about to reprint, because he's a serious modeler, not like me, and he did a wonderful job. You'll see it when the new PLA arrives. And as you can see, the old system worked nicely. The only things bad was the wobbling, because at that time I still had the old build plate, which now rests here, disassembled. Well, disassembled mainly only because we are trying to build another printer with those profiles. Let me make a short comparison between that one and this one. Quite a lot stiffer than the old one, isn't it? Now, combining all the things I've learned with the CoreXY, I'm trying to develop this new Y carriage, which will have, as you can see, the X motor over it. Now, some of you may think that will be a problem, because added mass produce a lot more inertia, and that's a problem when you're moving. You are prone to phenomena like ringing, to maybe the print skewing, if you are not pass me the term, if you don't brake good enough when changing direction on one axis. And well, it's all acceleration stuff. So in the old days we had two extruders, two motors. Now we have one. If you're asking why, it's because I've tried to print a woman statue on the printer, and the one of the extruders, the one which was not extruding, was hitting the print I was printing a lot. It smashed so much times the print that after, let's say, 20 centimeters of print, don't worry, they were just legs, so I did not waste so much material. Well, I wasted the print, and one of the legs fell off the build plate, and totally ruined the print. So that's why I'm moving to one nozzle. That's also something I've been seeing. It's being a standard. It's becoming a standard. Sorry, maybe because it's easier. Leveling two nozzles on the same plane. It's a tremendous job. it's something I literally say anyone try to avoid that, and maybe do as many people are doing now, one or 10 multiple filaments, and should be the solution. Now, the use case scenario, standard use case scenario for this printer should be printing parts, large parts that will be post-produced later. So, for example, by sanding, adding plaster, adding paint, sanding again, or whatever. For example, for doing those big parts, and not something that you just print and put on a shelf. Well, I did it with that one because it's a trash, because it doesn't fit, it's too small. Next time, think twice before printing, Eduardo. Anyway, the best solution I see for this one is to totally avoid the dual extrusion. Doesn't seem enough. So I have just one motor now for the extrusion, and that helps. You know why? Because less mass, but also less problems. I could use I firstly use 8 cables for each hot end. We have 40 cables here, standard, remember the drives on the computer. Still the same cable. Now I can use more if I want, but never found use for using more than 8 of them. So maybe I will use the extra cables for something like more power to the fans, or for example more things like LEDs, I don't know, or maybe what about proximity sensor? That sounds nice, does it? And that's exactly what I'm about to try. Not on this one carriage, but on the new one I'm printing right now. No, not printing right now, sorry. Will be printed shortly. And this one was the last CoreXY, which made me proud at the time, but the carriage made me proud, not the wall printer. It sounds lovely. As you can see, double fan, one extruder, and it had on the fans, now you don't see it here because the part is missing, of course. On the bottom part there is the attachment for this sensor, which I already bought, and I'm studying it and trying to use it on this build plate, because remember, this is not full aluminum, this is a debond. There is a tiny sheet of aluminum on the upper and the bottom part, and there is should be styrene in the middle. Should work anyway. So, well, that's all for now. Sorry for contracting so much information so fast in one video. Maybe I will print, I will make videos more often, maybe slower, and make them more understandable. Well, till next time, bye bye.